Welcome to my Artificial Intelligence through Artificial Intelligence YouTube channel and the Introduction to Deep Learning and PyTorch course. In this module, we will explore the role of activation functions in neural networks. To understand the concept of activation functions, it is essential to first grasp the difference between linear and non-linear relationships. Therefore, we will begin by exploring these two concepts. Firstly, let's see what is linear relationship. The easiest way to explain a linear relationship is that its graph shows a straight line. The function will be linear if the highest exponent of x in the equation is 1. The slope of a linear graph is the same everywhere, meaning the rate of change between the input and output is always the same. Now let's see the non-linear relationship. The simplest way to explain a non-linear relationship is that its graph does not form a straight line. The highest exponent of x is more than 1. For example, here, the highest exponent of x is 2, and in this equation, the highest exponent is 3. The slope of a non-linear graph changes all the time, meaning the relationship between input and output is not consistent. Now let me explain linear and non-linear relationship by a real-world example. Suppose if you drive a car at a constant speed of 40 km per hour, the distance traveled over time forms a straight line. This is linear. But if you start slow, gradually speed up, and then slow down again, the relationship between time and distance is non-linear because the rate of change is not constant. Now that we have a clear understanding of linear and non-linear relationships, it's time to dive into activation functions. Activation functions play a crucial role in neural networks by enabling them to learn complex patterns in data. They achieve this by introducing non-linearity, allowing the network to capture complex relationships that a linear model cannot. This nonlinearity enhances the network's ability to learn and generalize with high accuracy. They are mathematical functions applied to the output of a neuron. Without activation functions, neural networks could only model linear relationships between inputs and outputs. As shown in this figure, applying an activation function introduces nonlinearity, enabling the network to learn complex relationships. Without it, the model remains linear and fails to capture intricate patterns. Now let's explore the role of activation function in deep learning. An activation function, as its name indicates, decides whether a neuron should be activated or not. This means that it will decide whether the neuron's input is important or not in making prediction using simpler mathematical operations. The primary function of the activation function is to transform input, weighted sum plus bias, from a node into an output value to be transferred to the next hidden layer or to the output layer. A neural network without activation functions perform only linear transformations, making all layers behave the same, regardless of their depth. It means learning any complex task is impossible, and model would be a linear regression model. Now let's compare a neural network with an activation function to one without it. Observe the difference in their behavior and learning capabilities. That wraps up today's video. I hope you now have a good understanding of activation functions in deep learning. If you found this helpful, don't forget to subscribe, like, share, and comment to stay updated with this series.